In this video, we'll learn about exact differential equation. The general form of an exact differential equation is given by equation 1. That's m of xy dx plus n of xy dy is equal to 0. Consider the formula of curves given by equation 2. Then the total differential of equation 2 is given by partial of f with respect to x dx plus partial of f with respect to y dy is equal to 0. Comparing equation 1 to equation 3, we obtained partial of f with respect to x is equal to m of xy and partial of f with respect to y is equal to n of xy. And so these are the two main equations that we are going to use for an exact differential equation. How do we check if a given differential equation is exact? So consider equation 1. Then we say equation 1 is exact if partial of m with respect to y is equal to partial of n with respect to x. Then we can solve the given differential equation by this method. With our first question, we have to solve the IVP 2xy minus 6x squared plus 2y plus x squared plus 4 dy dx is equal to 0 with the initial condition y of 0 is equal to minus 3. To solve this differential equation, we compare our differential equation to the standard form, that's m of xy dx plus n of xy dy is equal to 0. And so here we need to multiply through by dx in order to get it in this form. And so we are going to have 2xy minus 6x squared dx plus 2y plus x squared plus 4 dy is equal to 0. And so we compare this given differential equation to the standard form. And so we are going to have m of xy to be given as 2xy minus 6x squared and n of xy to be equal to 2y plus x squared plus 4. Our next step is to check if this given differential equation is exact. And so we ask ourselves, is partial of m with respect to y equal to partial of n with respect to x? Now let's differentiate m with respect to y. And so we are going to differentiate this guy with respect to y. So we are going to keep x as a constant. And so differentiating m with respect to y, we are going to have 2x. Also, partial of n with respect to x will be equal to, so here we are going to treat y as a constant. And so we are going to have our results to be 2x. And so partial of m with respect to y is the same as partial of n with respect to x. Thus, partial of m with respect to y is equal to partial of n with respect to x. And so the above differential equation is exact. By definition, partial of f with respect to x is equal to m of xy, and partial of f with respect to y is given as n of xy. And so let's work with this first equation. Thus, we are going to say that partial of f with respect to x is equal to, now m of xy is defined to be 2xy minus 6x squared. So we are going to have 2xy minus 6x squared. Simplifying this, we are going to have partial of f is equal to 2xy minus 6x squared multiplying the x. Integrating both sides, we are going to have f of xy is equal to the integral of 2xy minus 6x squared del x. So we are going to integrate this partially, right? So we are integrating with respect to x. So we are going to have x squared y, then minus 2x cubed plus a constant. But in this case, the constant is a function of y. So let's call this guy, say, equation star, right? Now let's differentiate equation star with respect to y. So since we integrated with respect to x, we now have to differentiate this guy with respect to y. And so differentiating f with respect to y, we are going to have the f the y is equal to, for the first term we are going to have is to be x squared, so that will be x squared, and for minus 2x it will to go to 0 since it's a function of x only, then plus h prime of y. So let's call this equation, let's say, double star. Now let's compare equation double star to this equation that we have in here. So as we can see, partial of f with respect to y, and this is also partial of f with respect to y, which implies that the right hand side of equation double star should be the same as our function n of xy. And so we are going to have x squared plus h prime of y is equal to, then our function n of xy is given below. So we are going to have 2y plus x squared plus 4. Simplifying this, we are going to have h prime of y is equal to 2y plus x squared plus 4 minus x squared. And so this will be equal to 2y plus 4. So we have h prime of y giving us 2y plus 4. Our goal is to find h of y, so we have to integrate with respect to y. And so we are going to have y squared plus 4y plus a constant c. So we now have an expression for our function h of y. We now go back to equation star, right? So from equation star, we have the function h of y. But here we have h of y to be given as y squared plus 4y plus c. So we need to substitute h of y. So we are going to have a function f of xy to be equal to x squared y minus 2x cubed plus h of y, of which h of y is equal to y squared plus 4y plus a constant c. So this is our solution. Thus, the general solution is x squared y minus 2x cubed plus y squared plus 4y plus c is equal to 0. From the initial condition, we have y of 0 to be equal to minus 3. Thus, we are going to have 0 squared times minus 3 minus 2 times 0 cubed plus minus 3 squared plus 4 minus 3 plus c is equal to 0. And so you're going to have 9 minus 12 plus c is equal to 0. Thus c is equal to 3. Hence our particular solution is given as x squared y minus 2x cubed plus y squared plus 4y plus c, but c is equal to 3. So this is equal to 0. With our second question, we have to find the solution of the IVP. 2xy squared plus 4 is equal to 2, 3 minus x squared y dy dx. With the initial condition, y of minus 1 is equal to 8. So here our first step is to rewrite the equation in the form of m of xy dx plus n of xy dy is equal to 0. And so we first multiply through by dx. So that's we're going to have 2xy squared plus 4 dx is equal to 2, 3 minus x squared y dy. Now we move this guy to the left hand side, and so we are going to have 2xy squared plus 4 dx, then minus 2 out, 3 minus x squared y dy is equal to 0. And so we are going to have our function m of xy to be equal to 2xy squared plus 4 and n of xy to be equal to minus 2, 3 minus x squared y. We now check for exactness, so we check if partial of m with respect to y will be the same as partial of n with respect to x. And so let's compute partial of m with respect to y. So we are going to keep x as a constant in this case. When we differentiate this guy with respect to y, we are going to have 4xy. Now let's differentiate n with respect to x. And so we are going to differentiate this guy with respect to x. So 3 will go to 0 since it's a constant. So we are going to have minus 2, then minus 2xy, which is equal to 4xy. And so this differential equation is exact since partial of m with respect to y is equal to partial of n with respect to x. We now proceed to solve our given question. Now, by definition, we know that partial of f with respect to x is given as m of xy, and partial of f with respect to y is given as n of xy. And so let's choose to work with our first equation. And so we are going to say that partial of f with respect to x is giving us 2xy squared plus 4. And so our main goal is to find f of xy, right? So we need to integrate this equation with respect to x. And so we are going to have f of xy is equal to the integral of 2xy squared plus 4. So we are integrating this guy partially. And so we are going to have our results to be equal to x squared y squared plus 4x plus a constant. But since we are doing partial integration, our constant will be a function of y. Now let's differentiate our function f of xy with respect to y. We are differentiating with respect to y because here we chose to integrate it with respect to x, so we have to differentiate it in the other variable. And so we are going to have partial of f with respect to y will be giving us, so we are differentiating this function with respect to y, right? And so we are going to have 2x squared y. So when you differentiate for x with respect to y, you are going to have 0, then plus h prime of y. Let's observe something from these two equations, right? So we have partial of f with respect to y and partial of f with respect to y. But partial of f with respect to y is the same as n of, and so we are going to equate this expression to our function n of xy. Thus, we are going to have 2x squared y plus h prime of y is equal to n of xy, which is giving us minus 2, 3 minus x squared y. So now let's expand the right hand side. So we're going to have minus 6 plus 2x squared y. And so simplifying this expression, we are going to have h prime of y is equal to minus 6 plus 2x squared y minus 2x squared y. Thus, h prime of y is equal to minus 6. Now let's compute h of y. So h of y will be giving us, so you're integrating minus 6 with respect to y, so that's going to give us minus y plus a constant c. We have a constant because this is a function of one variable, so we're going to have it to be the constant of integration. Now we have the expression for h of y to be equal to minus 6y plus c. We substitute minus 6y plus c in place of hy to get our general solution. And so we are going to have our function f of xy to be equal to x squared y squared plus 4x plus h of y, which is now equal to minus 6y plus a constant. So our solution will be giving us x squared y squared plus 4x minus 6y plus c is equal to 0. Now from the question, we have our initial condition to be y of minus 1 is equal to 8. Thus we are going to have minus 1 squared multiplying 8 squared plus 4 times minus 1 minus 6 times 8 plus c is equal to 0. And so we are going to have 64 minus 4 minus 48 plus c is equal to 0. Thus c is equal to minus 12. And so our particular solution will be giving us x squared y squared plus 4x minus 6y minus 12 is equal to 0. With our third question, we are to solve the differential equation x squared minus 4xy minus 2y squared dx y squared minus 4xy minus 2x squared dy is equal to 0. Here, our first step is to compare the given differential equation to the standard form, that's m of xy dx plus n of xy dy is equal to 0. And so comparing these two equations, we have m of xy to be equal to x squared minus 4xy minus 2y squared, and n of xy to be equal to y squared minus 4xy minus 2x squared. Our next step is to check if partial of m with respect to y is equal to partial of n with respect to x. Let's compute partial of m with respect to y. So we have to differentiate this guy with respect to y, and so we are going to have minus 4x minus 4y, and also partial of n with respect to x will be giving us, so we have to differentiate this guy with respect to x, and so we are going to have minus 4y minus 4x. And so as we can see, partial of m with respect to y is the same as partial of n with respect to x. And so the above differential equation is an exact differential equation. By definition, partial of f with respect to x is equal to m of xy, and partial of f with respect to y is equal to n of xy. So here let's choose to work with the second equation. And so we are going to say that partial of f with respect to y is equal to y squared minus 4xy minus 2x squared. Simplifying this, we have partial of f is equal to y squared minus 4xy minus 2x squared partial of y. Our main focus is to find f of xy, so we need to integrate both sides. So we are going to have f of xy is equal to, so we are going to integrate with respect to y. So we are going to have y squared minus 4xy minus 2x squared partial of y. Integrating this, we are going to have y cubed on 3 minus 2xy squared minus 2x squared y plus a constant, but in this case we are going to have it to be a function of x. We now differentiate f with respect to x, and so we are going to have partial of f with respect to x to be equal to minus 2y squared minus 4xy plus h prime of x. Let's call this equation A. By definition, we have partial of f with respect to x to be equal to m of xy. And so we are going to equate the right hand side of equation A to m of xy. And so we are going to have minus 2y squared minus 4xy plus h prime of x is equal to m of xy, which is giving us x squared minus 4xy minus 2y squared. Simplifying this, we are going to have h prime of x is equal to x squared minus 4xy minus 2y squared, then plus 2y squared plus 4xy. This guy will cancel this guy, and also this will also cancel that. And so our expression simplifies to h prime of x is equal to x squared. Now let's compute h of x. So we're going to integrate with respect to x. So we're going to have x cubed on 3 plus a constant c. Now we have the expression for h of x. We are going to substitute it in equation b. And so we are going to have f of xy to be equal to y cubed on 3 minus 2xy squared minus 2x squared y, then plus x cubed on 3 plus a constant c. Hence, our general solution will be giving us y cubed on 3 minus 2xy squared minus 2x squared y plus x cubed on 3 plus c is equal to 0. And so this is our general solution to question 3.